Hey, Year 10s, let's take up Assessment 3 so that we can move on. So, first of all, well done. 100% on this question. We now understand the conversion between lengths, but also areas and volumes. So I'll just go ahead and put the answers up here, but I don't feel we need to go over this anymore because we have explained this. Right, number 2, similar pyramids. This is one that you had a lot more trouble on. So let's go over this. First of all, you're given the surface areas of Pyramid A and Pyramid B. So when we're working out the scale factor, you have to keep in mind that with areas, the surface area of one is not just the scale factor times the surface area of the other, but the scale factor squared. Area, squarea. Just like we learned in the previous question, when you're converting areas, you multiply by the scale factor squared or the conversion squared. Same thing with when you're talking about similar shapes. Okay, so we can work out the scale factor squared here. If we know the surface area of A is 765 and we know the surface area of B is 85, we can just go ahead and rearrange and solve this equation to get the scale factor squared on its own, move the 85 across. It's multiplied, so we'll divide. And then to get the scale factor, we just need to square root, because the opposite of squaring is square rooting. So the scale factor will be 3. Now, knowing that the scale factor is 3, when we're working out our ratio for the heights of the pyramids, we have to keep in mind that heights, unlike areas or volumes, they're one-dimensional measures. A height is just a length in a different direction. So we just need to multiply by the scale factor, not the scale factor squared or the scale factor cubed. So we're multiplying by 3 here. Setting up our ratio, we could use the fact that the height of A is equal to the scale factor times the height of B. So when I set up the ratio, and I'm putting it in the same order as the question here, the ratio of A to B, so height A to height B, I'm going to replace A with scale factor times height B because I know that they will be equal to each other. So A is the scale factor times height B, and height B is just height B. I know the scale factor is 3, and I want to simplify this ratio. I'm writing a simplified ratio for the height of A to the height of B. So to simplify this, I can divide both sides of this ratio by the height of B, which will just leave me with 3 on this side, and divide the height of B by itself. It gives me 1 on that side. So my ratio is 3 to 1. I have a feeling a lot of people got the order mixed up, which is a real shame because we would have done everything else right. So the ratio is 3 to 1, not 1 to 3. The order is the same as the terms in the question. Next, this one went quite a bit better, 65% got it right. So taking this up, the surface area of this solid cylinder and hemisphere shape. To work out the surface area of this shape, I need to work out the curved hemisphere face. So that is just the curved bit, not the circle, because the circle is touching the end of the cylinder. It's not an outer face. The curved cylinder face, which is basically just a rectangle that is wrapped around this circular shape, and the circular face that's here at the end, right? So I've set up my formula here for that. This is the surface area of a full sphere. This is a hemisphere. It's half a sphere, so I'm dividing it by 2. This is the area of the curved surface area of a cylinder, which is 2 pi r, which is the circumference of a circle multiplied by h, the height of the cylinder, because it's basically a rectangle that wraps its length around a circle, 2 pi r, and its width is the height of the cylinder. And finally, pi r squared is the area of the circle here. I just simplified that before I substituted it into it to make it easier for my calculation. 4 pi r squared divided by 2 is 2 pi r squared. Everything else is the same. But seeing that, I've got 2 pi r squared and I've got another pi r squared together here. That would make 3 pi r squared. And now I can't simplify any further, so I'm going to go ahead and substitute in. I know the radius is 1.2, and I know that the height of the cylinder is 3.5. So I've got 3 pi radius 1.2 squared plus 2 pi radius 1.2, height 3.5. That works out to be 1.44, that's the 1.2 squared. And these two multiplied together gives us the 4.2. I've just put my numbers in front of my pi's. Now I know pi's are numbers as well, but I'm still using them as variables here because I'm working out an exact value. So I'm not going to use pi on the calculator. I'm just going to work out how many pi this is. So multiplying this through That's going to be 4.32 pi, and this makes 8.4 pi. Together, it's some number of pi. I can just add the 4.32 plus the 8.4. That's 12.72 pi. Exactly. I never rounded at any point there, so that's an exact answer. 12.72 pi. Right, this question area and perimeter of a sector went a lot better. 90% got the radius right, and 75% got the perimeter right. So we shouldn't take too long taking this up, but we'll go through it quickly. Now, if you're given the area of this sector, you should not be ignoring that. The very first thing you should be doing is writing the formula for the area, and then using the given area, set up an equation you can solve. So the formula for the area is a fraction over 360, so 32 degrees because it's 32 degrees of the angle, over 360 times the area of a circle pi r squared. And that we're told is equal to 20 pi. Rearranging that to get the r on its own, I'll take the pi to the other side. Here it was multiplied, there I'll divide, so that's why it's on the bottom of this fraction. And this fraction here is multiplying by r squared, so I'm going to take it over to the other side and divide. But I've done this in one step here. I know that to divide by a fraction, I need to flip it over and multiply it. So rather than being 32 over 360, I've got 360 over 32. Okay, simplifying that down, I know I can cancel out my pi's. I can divide the top by pi, which will leave me with just 20, and divide the bottom by pi, which will leave me with just 1. So I could say that that's really just 20 times by 360 over 32. So I've got 20 times 360 over 32. Simplifying that to get the r on its own, the opposite of squaring is square rooting. So this works out to be 225, and I am square rooting 225. So r is 15. I've got my radius is 15, and we need our radius in order to move on. So I'm glad that 90% of you got the radius right, because you can't get the perimeter without it. Now to get the perimeter, we're going to add up all of the sides of this sector, which includes one arc and 2 radiuses, or 2 radii. Okay, so I'm doing arc length plus 2 radii. Now, this is maybe where the 75 or the 25% lost their marks, is you might have forgotten to add on the 2 radiuses and you worked out the arc length only. So working out the arc length, that's the hardest bit though, is that it's a fraction of the circumference of the circle, that fraction being the angle that we see here out of the full circle, which would be 32 over 360. Times that by the formula for the circumference of a circle, 2 pi r, and don't forget to add on the 2 radiuses because we've got 2 straight sides that make part of the perimeter of this shape. Okay, working that through, we've got 32 times 2. I've just taken this 2 here, multiplying it by the fraction. I multiply it up at the top, and then I've substituted in my radiuses. My radius was 15, so I've got 2 pi r becomes 2 is up here, pi 15, and 2 times radius, 2 times 15. Simplifying that down, that's going to be 64. And I've taken my 15 and I put it in front of my pi just to work as accurately as I can, working in exact values. I've left the pi out for now. So I've done 64 from the 32 times 2 times the 15 over 360. And the 2 times the 15 made the 30. Okay, that can be simplified. So that works out to be 960 over 360 pi plus 30. Now this is an exact answer right now. It could be simplified because of course I could divide both the top and the bottom by 30 here, but it is some number of pi plus some other number. Now we want the 3 significant figures answer, so I'm going to keep calculating that. That's approximately 38.37758.041, and that's run off to the end of my calculator. That's not the exact value, so I'm going to need to round it. 3 significant figures, 38.3 with a 7 after it. That 3 is going to round up. That's 38.4. Right, so my perimeter is 38.4 centimeters. Last question, the volume and surface area of pyramids. Now, the first part of this went quite well. We know how to find the volume of a pyramid, but the surface area of the pyramid, that's where the problems came in. Okay, so let's go through the volume quickly then. The volume of a pyramid, we should know by now, is 1/3 the area of the base multiplied by the height. To make this easy on you, I've given you a pyramid where the base is just a square, so it's length times width, and the length and width are both 5. And the height of the pyramid, which was given, was the square root of 12.5. Normally this question wouldn't give you that height, but I'm trying to go a bit easy on you. You would have had to work that out using a combination of Pythagoras. Okay, so substituting that into the formula, 1/3 of the area of the base being 5 times 5, multiplied by the height, which is square root of 12.5. That is 5 times 5 makes 25. I've put it at the top here, multiplying that by 1, so that's 25 times 12.5 square rooted. Now you're going to see this format a lot in year 11 where we don't need to write the multiplication sign in between a rational number, that is a whole number, not underneath a square root sign, in front of an irrational number, which is a non-square number underneath a square root sign. We call it irrational because there's no way that I could write that number exactly as a fraction. I would have to leave it under a square root sign to keep it exact. Okay, so we want our answer to 3 significant figures though. This is the exact answer. Calculating that out though, that would be 29.46278255. Now that's obviously run off the end of my calculator there. That is not perfectly accurate, as you can see by the symbol we've got in front there. The 3 significant figures, that would be 29.4 with a 6 after it. That's going to round the 4 up. That makes 29.5. So my volume 29.5, and 90% of you got that right. Well done. The surface area is a little bit more difficult, although it's just the sum of all of the areas of all of the faces of the shape. And the faces of the shape is 1 square and 4 triangles. And those 4 triangles are all the same size because I've got a square base. That means the base of all of these triangles is the same. They're all 5. And we're told that all of these edges that go up the side of this pyramid are all also 5. So I know that all the edges are the same, all the sides of all of the triangles are the same. These are equilateral triangles with side lengths of 5 centimeters. So I'm going to say the surface area of the pyramid, in this case, is the area of the square plus 4 times the area of the triangular faces. And I can say that because these triangles are all the same size. If they were different sizes, I would have to work them out separately and add them together. Okay, the area of the base, again, it's a square and the side lengths are 5 and 5. So that's going to be 5 times 5 plus 4 times the area of the triangular faces. Now I've used this formula here, the area of any triangle, because it's not a right angle triangle. I could split this down the center to make it a right angle triangle, and then I can work out the height of that using the fact that the hypotenuse is 5, the base is half of 5, so 2.5, and Pythagoras to find the height. But I've decided to use this formula because I know that this is an equilateral triangle. I know all of the sides, and I know all of the angles. All of the angles will be 60 because 60 plus 60 plus 60 makes 360. So to use this formula, I need to know 2 side lengths and the angle between them. My 2 side lengths will obviously be 5 and 5, and the angle between them will be 60 because all of the angles are 60. So working this through, 5 times 5 is 25, plus 4 times this fraction, I just multiply the top by the 4. So I've got 4 on the top, multiplied by A, which is 5, one of the sides of the triangle. B is the other side of the triangle, also 5. And the angle between them is 60. Simplifying that down, that's going to be 25 plus 4 times 5 times 5, that's 100. And sine of 60, that's an irrational number. That's why I've got this symbol out here. I didn't want to write out all the digits of it, so I've just written 3 significant figures, but I'm using the exact value from this in my calculation, and I'm leaving a rounding till the end. So this works out to be 68.3. Now that's been rounded to 3 significant figures. You can see my symbol there. So my answer, surface area to 3 significant figures, is 68.3. Okay? Now, this assessment went way better than assessment 1 and assessment 2, which it should because we've had the practice on it now. But I hope that you're starting to feel a lot more confident about this and you're feeling ready to move on. Right. Well done, guys.